Triple integrals in cylindrical. This is the first of several videos where we'll go through some examples. Well, recall cylindrical coordinates is really polar with an added z coordinate. So we have r and theta from polar. The z coordinate is just the height. Drop this down to the xy plane. This would be the point x, y, 0. And the distance of the origin is r. This polar angle is theta, counterclockwise from the x-axis. Here's all the basic equations of the transformations from polar to rectangular and back. X equals r cos theta, y equals r sine theta. That's from Calc 2. Z equals z, that doesn't change. R squared is x squared plus y squared. Tan theta is y over x, basic right triangle trig. Now a volume element, it's really pretty easy. This is an area element, this little sector of a circle, a truncated sector I think it might be called, where dA is r d theta, the height is dz. Well, you just multiply area of the base times height. There's the area of the base dA times the height. That gives you an element of volume. So any volume integral in cylindrical would be dz r d theta. Doesn't have to be in this order, but that's usually the most convenient order to think of. So let's suppose theta goes from 0 to 2 pi, and r goes from 0 to 2, and z goes from 0 to 2. Very easy to set up the integral. 0 to 2 pi, r goes from 0 to 2, and z goes from 0 to 2. Now, like before, the question is, what is it? What solid region did we set up the integral over? Well, theta goes from 0 to 2 pi, r goes from 0 to 2 in polar. That's just a circle, except now our circle happens to be horizontal instead of vertical because our xy plane is horizontal. And then z goes from 0 to 2. For each point in here, we start here and go up here. Right down here, z equals 0, and you can draw new axes up here. Z equals 2, and guess what? We end up with a cylinder. Not surprisingly, in cylindrical coordinates, limits of integration are constant if we integrate over a cylindrical solid region. So anything we're doing, if we wanted to find the moment of inertia of a cylindrical object that was spinning about the z-axis, cylindrical coordinates is where it's at. Very easy to do the derivation. So let's suppose we alter this a little bit to pi over 2. Then, of course, very easy to alter our integral. And, of course, what solid region do we have? Well, we're limited to the first quadrant, so guess what? We have something like this. And it's a quarter of a cylinder, quite simply put. And of course, this would be 2. You can label the z-axis. And of course, this would integrate. This would give us 1/4 of what the previous answer was. So we'll be back for a second.